Good morning, guys. Am I audible to all of you?
Yes, sir.
Yes, sir.
And
Yes.
my screen is also visible to all of you, right?
Right, sir.
Yes. Right.
Okay.
Right.
Yeah. So basically, today we are going to complete our asynchronous programming, and from tomorrow we are going to start another important concept that is parallel programming, and that is also basically from you can consider that is also one of the important concept that you need to understand if you want to improve your overall application performance, right? So guys, multi-threading is different. Asynchronous programming, what we are discussing now, that is also different, and that is what we are going to discuss from tomorrow, right? Parallel program, that is also going to be different thing, right? We have already completed multi-threading, and currently we are working with a asynchronous programming. You can say asynchronous programming is an advanced version of multi-threading, right? And main use of asynchronous programming is so whenever you want to communicate with some external system, right? You are going to call some database operation, you are going to consume some API, right? You are going to read the data from some files, right? For that particular purpose, you have to use asynchronous programming. And whenever you want some CPU bound operations, right? So in your application, there is a heavy for loop, right? Which is going to execute for 500 time, 1000 time, and each time you are executing the for loop, it is going to be take some time to do the task, right? Or you are having some heavy operation methods within your application, right? And those operations are independent, right? Instead of calling them one by one, you can execute them parallelly, and for that purpose you need to use parallel programming. That is what we are going to discuss from tomorrow onwards, right? Which on mute, right? So today we are going to complete this task based sorry, this asynchronous programming, right? So as of now, right, as of now we have discussed already the task class. And we know that so whenever we are creating any async method, right? And if you want to return something, right? Or if you do not want to return something, then in that case, you are using task and a task of a T, right? You basically use a task when you do not want anything to be written from your asynchronous method. And you have to use task of a T whenever you want to return a T value from your asynchronous method. So basically, task is used to implement asynchronous programming, right? And this concept, as we already discussed, was introduced as part of a .NET Framework 4.0. And we have already discussed that all the task-related classes are belongs to system.threading.task namespace. So can anybody tell me all the threading-related classes belongs to which namespace, guys? If I'm going to if I'm going to create a class of a mutex, right? Semaphore, thread, right? So all these classes are belongs to which namespace?
System.threading.
System.threading namespace. And this task, it is nothing but it is also related to threading. It is an advanced version of threading. So you can see this is not going to be come from a different namespace altogether. It is as part of system.threading, but it is a child namespace, you can say, that is tasks, right? All the task related classes are belongs to system.threading.task namespace. So if you are going to use any task related activities, right? If you are going to consume any of the task class, right? First of all, you need to import which namespace in your application, system.threading.task. And once you implement this namespace, right? Then you can consume or you can use task related classes, or you can create instances of a task related class, anything that is related to task, you can implement, right? In general, the task class will always represent a single operation, and that operation will be executed asynchronously on a threadful thread rather than synchronously on the main thread of the application. As you already discussed, if you are creating one async method, right, then that method is going to be execute, right? If that method is going to be, so suppose you are calling some async operation, right? Then that is going to be executed by a different thread, and that thread is not your main thread, right? That is going to be executed asynchronously, and that thread will come from where? From the thread pool thread, right? Whenever you are implementing asynchronous programming to execute the asynchronous operation, right? That operation is going to be executed asynchronously, and that operation is not going to be executed by your main thread. Rather, it is going to be executed by the thread pool thread, right? Thread pool thread, we have already discussed that concept called thread pooling, right? So from thread pooling means that is a pool of a thread and one of the thread will come from the thread pool, will execute your task, and once the task execution completed, it will again go to that thread pool so that the same thread can be used to execute another task, right? So we have already discussed async and await operator, right? We have already discussed async and await keyword to implement asynchronous programming, right? Now, what we are going to understand is we are going to discuss how to implement asynchronous programming using the task class. Previously, if you see, right, whenever we implement any asynchronous method, right, that method is going to return a task. That method is going to return a task, and that task is going to be executed asynchronously. Yes or no? Suppose I am creating one async method, right? And the return type is going to be task or a task of a T, right? That means that method is going to return a task, and that task is going to be executed asynchronously. So instead of making or instead of marking the method as async, and while calling the method using the await operator, so what we are going to do, we are going to use the task. So this task class is similar to your thread class, right? So if you want to execute a method using multi-threading, then how you can do this? First of all, you need to create an instance of the thread class. To the thread class constructor, you need to pass one method, right? And that method signature must be matched with the parameterized thread start delegate or thread start delegate. And when you invoke the thread, right, then the method which is pointed by the thread class constructor is going to be executed. Right? In that case, in that in that case, what happened? In that case, the thread which we created is going to consume the application code. The same thing we can also achieve using asynchronous programming, right? Using the task class. What we need to do? We can create an instance of a task class to the task class constructor, which is expecting one action delegate. Expecting one delegate means we can pass a method which signature is matched with the delegate signature, right? And when we call the start method of the task class, right, the method which is pointed by the task class constructor is going to be executed. The difference between multi-threading thread class and this task class is that in the case of a thread class, give me 1 minute, guys. In the case in the case of multi-threading, the thread what we created, that thread is going to execute our application code. But in the case of a task-based asynchronous programming, we are not going to create the thread. The thread which is going to execute our method code asynchronously is going to be the thread pool thread, right? Let me show you these things practically so that you will get a better clarity, right? So in this case, you can see, let me close this one. Okay. So in this case, you can see this is my print counter method, right? The name is print counter because it is going to print the count number from 1 to 5. I'm not going to, you can do anything, right? So in this case, what I'm saying now, whenever this method execution started, which thread is executing my application code, that thread ID I'm printing. And after that, I'm looping through this 5 times, right? So you can see the count value from 1 to 5, right? And then I'm printing that this child thread complete its execution. This is a simple method. You can say this is a simple function. And how to get the thread ID? You know, thread.current thread.manage thread ID. This is going to give you the unique ID, which is the thread executing this application code. What is the ID of the thread that executing this application code? That thread ID it is going to print, right? And you can see we are going to create an instance of a task class, right? If you go to the definition of task class, right, you can see it is expecting one parameter of action type. What is action? If you go to the definition of this class of this type, then you can see it's a delegate. And this delegate taking how many input parameter? 0. This delegate is going to return what type of value? It is going to return void. That means what? Now to this task class constructor, we can pass, say, okay, I will show you both the approaches. First of all, can I create an instance of a action delegate, and to this instance, can I pass this print counter method?
Yes.
Why? Because it's a delegate, and this delegate signature is the same as this method signature. So I can pass this method to this action delegate. Once you create the action delegate, can you pass that action delegate instance as a parameter to this task class constructor?
Yes.
Yes.
Right. Why? Because it is expecting one action delegate, and that is what I'm passing here, right? But as we already discussed, this task no, I'm going to execute one delegate whose method signature should be the return type is going to be void, and the method should not accept any parameter. So instead of doing these two activity, right, manually, creating an action delegate, passing that method and all these things. So what you can do is you can directly pass the method signature that is same as this action delegate as a parameter to here, right? This is also going to be work. We have already discussed this thing. So directly you can also pass the method name as a parameter to this task class, and this is possible. Why? Because the method what I'm passing here, its signature is same as this action delegate. Clear? Any two option.
Yes.
You can use this one or you can use this one, as this is reducing the number of line of code, right? I can go with this one, but if anyone new, then he should do this thing, because he needs to know what is action delegate, how to create an instance of delegate, how I can pass this method signature as a parameter to this action class, this action delegate, right? And then you can pass that instance as a parameter to this thing. These two statement can be simplified by using a single statement, right? Once you create the task class, right, then you can call the start method. And once you call the start method, right, then what will happen? It will start executing this method, right, which you passed as a parameter here, or the method which is referred by this action delegate, right? It will start executing that method asynchronous, asynchronously by using the thread pool thread. If I'm using threading, right, for example, if I will create like this, suppose you can also execute this thing by using a thread class, thread one equals to new thread, and to this thread class constructor I can pass this thing, right? And then thread one dot what? Well, tell me.
Start.
Right? So this thing I can do this. Then in this case, this method is going to start executing. In this case also, the method is going to start executing. Then what is the difference between these two things? Can anybody tell me?
The thread is going to execute. The task is going to execute asynchronously.
Yes, this is also going to execute
Yes.
asynchronously.
On line number 16, like thread is creating automatically. Line number 19, we are like explicitly like creating a thread which
No, no,
perform the
no,
same.
no, no, no.
Task is going to use thread pool, and thread is
Exactly,
going to.
exactly. So in this case, the task is not going to create any new thread. It is going to use the already created thread that are already available in the thread pool. That thread creation activity is not happening in this case, but that thread creation activity is happening in this case. So in this case, we are creating the thread manually, and that thread is going to execute my application code. But in this case, the thread is not going to be created. It is going to use the thread pool thread to execute the application code, right? Clear? Right? Is that clear? Guys?
Yes.
Initialize a system with the specified action, the delegate that represent the code to execute in the task, right? Basically, here you need to pass one delegate, and that delegate will pointing to that code where to execute the start, right? Where the code is going to be executed from where. That is what this print counter method. So we are not going to supposed to discuss this thing, but I just show you, right? So to make you understand what is the difference between task class and thread class. If someone asks you what is the difference between these two class, right, the working activity, right, you can see both are going to work in the same manner, right? So it is going to execute this print counter method, it is also going to execute the print counter method, and whenever we call the start method, here also we are calling the start method. The only difference is that in this case the thread is being created and that thread is going to execute the application code, and in this case the thread is going to come from the thread pool, right? That means this will give you better performance comparing with this one. So all obviously, why we are using task? Because to simplify, because to utilize the multi-threading concept effectively, right? That is the main agenda of asynchronous programming. And if both are going to do the same thing, then why I'm going to use this one? Why I'm going to use a task class if both are having the same functionality? I can go with the multi-threading, but yes, this is not possible. So in this case, thread pool concept will not come into the picture. In this case, thread pooling will come into the picture. Now run the application, and once you run the application, then you will see that, right, before completing the execution of this print counter method, this task, this main thread will complete its execution, right? It's not guaranteed, but for this example, you can see main method started, main thread start, main thread end, and then you can see other things, right? So you can see the main thread which ID is 1 and main thread is completed. Child thread ID is 3, child thread completed. So you can see both are executing asynchronously, right? Clear? So now you can
Yes.
see, I'm not using async and await operator. I'm not returning a task. Rather than I'm creating a task, and that task is going to execute the application code, right? This is same as async and await, but here I'm not returning anything from. I'm not making this async and await operator, right? Async and await operator comes later, right? Before that, we have implemented task-based asynchronous programming by using task and task of T, right? So these things are still exist. You have, if you want, right, you can use the task like multi-threading, right? So this is similar to multi-threading, but the only difference is that in this case, the thread pool thread will come into the picture, right? Guys,
Yes. So what is the
okay.
best approach? Like, do we need to go for like a task based or like async away?
I think I would, obviously, I think I would, right? So that's basically very simple. We are not interested to create the task. We are who is going to call the start method, delegate, all these things. We need to hide. Simply make this method as async, and just call this method like a normal method, right? So if you see in this example, we created the task object and then call the start method, and then it is going to execute the things, right? But in the same way, there are other approaches also, right? So in this case, if you look at this method, right, how we are executing this method means we are creating, right? We are creating an instance of a task class. To the task class constructor, we are passing the method, right? Along the same way, there are other options are also available to execute the task method, right? What are these? Let me create another instance. So in the task class, right, there is a property called a factory, and within this factory, there is a method called start new. And to this new method, we need to pass the method that what we want to execute. So in this case also, right, the method is going to be executed. So, right. So the way we have created these two statements, can be simplified by using a single statement like this, right? So if you go to the factory, then you will see that it's a property, right, of the task class, which is returning a task factory, right? And if you go to the task factory, then you will see that it's a class. And inside this class, there is a method called start new, right? Which is taking what type of a parameter? Action delegate, right? So basically, if you remember, this task class having a property called factory, which is going to return task factory, and within the task factory method, right, sorry, within the task factory class, there is a method called start new, right? And that start new method accepting one argument action delegate. So you can pass this print counter method directly, or if you want, right, if you want, then you can create an instance and you can pass that instance as a parameter here, right? Both the approaches are exist, right? So in this case, whichever approach you want and whichever approach you like, you do, right? So I have shown you one example using print counter. Let me show this example using the start new delete. So this is another approach of executing one asynchronous method, right? So let me run the application. You are going to get the same output. Is that clear? So one is task class start method, create an instance of task class, call the start method. Another approach is task dot factory dot start. By using the start new method, we can invoke an action delegate. What is the difference between these two? Now, in this case, right, in this case, the task is created and manually we need to start the execution, right? Once you call the start method, right, then only this print counter method is going to execute asynchronously by using a thread pull thread. But in this case, if you are using start new method, right, then automatically the method, right, whatever this action delegate pointing to, right, automatically that method is going to execute asynchronously by using thread pull thread. Clear? In this case, you have to call the start method. Until and unless you are not calling the start method, this method is not going to execute asynchronous. In this case, no need to call the task method. As you are using start new means this action delegate, what the method it is pointing to, that method is going to execute automatically, and that method is going to execute asynchronously. And again, in this case, it is going to execute by thread pull thread. And in this case also, this method, right, what this action delegate pointing to, it is also going to be executed by the thread pull thread. Clear?
Sir, one doubt. This task class or task method using what we are doing, will it uses the multiple threads or it'll use single thread? I mean, like from thread.
So first of all, you just tell me what do you mean by multi-threading?
Multi-threading means parallel. I mean, like simultaneously, there will be more than one thread which will be created
Okay,
to
right,
execute certain task.
right, right. So in this case, right, so in this case, as I have shown you in the previous example or in this example, how many threads are executing your application code?
Two threads.
Two threads means it's a multi-threaded application or not?
Yes. Yeah.
The main so basically what is your question? I don't understand.
Suppose like my basic question was how it differs from async and await
It is
exactly.
not a differ. It is not a different from async and await. That is what I'm saying. I'm saying using async and await, you have implemented asynchronous programming. Using and in that case, you have whenever you use async method, that method is going to return a task. What is the return type of async method you generally use? Either you use a task or a task of a T,
Yes.
right? If you are using task means method is not returning anything. Task of T means method is returning something, right? So instead, in that case, the method is going to return a task, and that task is going to be executed asynchronously by the thread pull thread. So in this case, what I'm doing, I'm creating a task, right? I'm not returning this task from a method. Instead, I'm creating the task. And to this task, I'm passing the method that what I want to execute by this task asynchronously. So basically, using async and await, you can implement asynchronous programming, right? But the same thing you can also implement by using this task class. There is no differences. Yes, what is the differences? Async and await simplifies our job. So in this case, as you can see, who is going to remember this task, class, factory method, start new properties, what is this action delegate? In this case, task and the task of all these things is very difficult to remember and understand, right? For that purpose, right, they have simplified the things by using async and await. There is no difference. It is one of the approach to implement asynchronous programming. Async and await is also there to implement asynchronous programming. Right? Whenever if you are using asynchronous programming and if you are doing some time-consuming operation, right? Right. Suppose you are calling one async method, then that method execution is going to happen asynchronously. Right? For example, right? Right. So suppose print counter one, two method, right? So what I'm doing, I'm making this method as async and a task, right? So what I'm doing here, I'm making this as await. Then I'm using a task dot delay. I'm making this execution delay for 1 second. I'm making this loop to execute for 3 times, right? So, okay, so do one thing instead of doing this loop, I'm just putting these things 500. I'm commenting this one, right? And from this class, what I'm trying to do is because if you want to call one async method, then you have to call from where? Asynchronous block. So what I'm trying to do here, this is some method thread. This is some method thread. Let me comment this block. Right? This is my main method, right? And from this main method, what I'm calling the sum method. Right? So in this case, let me run the application code. Right? So in this case, you can see everything is going to be executed by which thread? Main method, sum method, executed by which thread? One. Print counter thread is executed by which thread?
Thread pool thread.
See, in this case, as I already told you, right? The execution will start by which thread? Main thread. Let's assume the thread ID is 1. Then the same thread is calling the sum method. Yes or no?
Yes.
That means the thread ID is going to be 1.
1.
Then it is calling which thread? Which method? Print counter 2. The same thread is going to be executed here, right?
Yes.
And in this case, this is nothing but your asynchronous operation, right? And in this case, right? In this case, what will happen? You are using the await keyword. As you are using the await keyword, right? So does this main thread wait till this method execution, completed?
No.
So in this case, as you are using the await keyword, means this thread will be released.
Yes.
So once the thread is released, then this will execute this statement by the same thread 1.
Yes.
The same thread is going to execute by this 1 also.
Yes.
But after 5 seconds, right, as you are using await, the thread, right, the thread will come from where?
Thread pool.
Thread pool means that thread might be a different ID.
Yes.
That means in this case, you can see a different thread ID like 527 like this, which is going to complete the execution of this method. Yes or no?
Yes.
Right. So now if you run the application, see, you can see, see print counter two threads. See, first of all are started with the thread one, but print counter two thread. What is the idea of that thread? 4. Why it is not same as one thread? Because it released the main thread, na. So it released the main thread. So then when the 5-second time interval is completed, right, as you are using await, so in this case to execute the next statement in this method, the thread will come into the picture.
So can we check that like a two different thread via like a debug Windows thread?
It's completely showing you the ID. You
Okay.
can see what is the ID. I'm not I'm printing this ID.
Yeah.
So which thread is executing your application code? That thread ID I'm printing here, right? And you can how you can debug these things. This is a different method altogether. It is making calling to an asynchronous call, right? Might be an API, might be an some different system, right? So, and for that purpose, I'm printing the ID now, which thread is executing your application code. This statement, right? Particular this statement, you can see which thread is executing that thread ID I'm printing. And in this case, one. One is basically your main thread, right? And you can see this statement after this await operation, which thread executing the rest of the code. That ID I'm printing here,
Yes.
right? So basically, if you are using asynchronous in this case, right? So what will happen now? Whenever we are doing this asynchronous operation, right? At that time, a different thread will come into the picture, right? It is not see in this case, this is the async operation which you are calling to an external API, right? At that time, as you are using await, see, so in this case, let me do one thing. I'm not using the await. I'm not using await. I'm simply writing task.delay. Then what will happen? Let's see. Can anybody tell me what will happen?
It will skip that and
There will be no thread, no new thread will come into the picture because it is not, you are not using await. If you use await, right, then only it will release the thread, na? As you already discussed, when it is going to release the thread when you use the await keyword. In this case, am I using the await keyword while calling this method?
No.
No. So if you are not calling the await keyword means what? This thread, the right will not release the main thread. The main thread is going to execute the application code. Now let me do one more thing, right? So let me use the await keyword here, right? Let me use the await keyword here also, right? Let me run the application. See, you can see a main thread, some method print counter to main thread completed with 1, right? Print counter to 4, some method 4. Why? Because in this case, right, in this case only a new thread will come into the picture because you are using await means main thread is released, right? This statement, what you can see here, is going to be executed by a different thread, and this statement is also going to be executed by a different thread. Is that clear?
sir, can we wait in task method as like for an API to call or return something from there? Can we wait the similar fashion like async and await in task?
That is what I'm going to discuss. Why you are in a hurry?
Okay.
If I'm discussing means in this case, I also going to discuss how you can make sure the task is completed before executing the further statement. That is what I'm going to discuss.
Sir, what is difference between task.run and this task.factory.start new?
So task dot you just tell me. In this case, right?
Task.run.
Right? Sorry. Yeah, I
Task.
run. I'm going to come into that also. I'm going to show you task start method, start new method, I'm also going to show you the task.run. Don't worry, everything I'm going to discuss in today's session, right? But what I have discussed as of now, and if anything doubt, then you can ask. So in this case, like this. So here, when a new thread will come into the picture when you use the await keyword, right? But in this case, if you are using the task, right, then in that case, so we are simply uploading the main thread task. So if you are creating a task, or if you are executing the task using start new method, right, then in that case, you are simply uploading the work of a main thread, right? That means what? Now to execute this task, right? This task means whatever the method or whatever the logic you want to execute by the task, right? That is going to be executed by a different thread, right? And in for that purpose, right? You can see in this case, when I'm using the await keyword, then only the thread is released and the rest of the code, right? What you have written, that is going to be executed by the thread pull thread, right? But in this case, let me comment these things, right? So let me comment these things, right? So in this case, right? So in this case, you can see I'm using the star new print counter. What is the name? Okay, let me comment this one. Let me uncomment this one. Okay, let me remove this one. This actually making lots of confusion, right? Right. So in this case, you can see, so this main method code is going to be executed by main thread, and this print counter, right, method is going to be executed by a different thread, right? Let me run this application. See, a different thread. Previously, the thread ID was 4. Now the child thread ID, you can see it is 3. So means what? Means you cannot simply predict which thread is going to execute your application code. Why? Because the thread is coming from the thread pool, right? So main thread ID is 1, you can see here, but other things, right? Child thread, you can see it is 3. In our previous example, we have seen that by 4, 5. So simply you cannot predict the child thread because this thread is going to be is coming from the thread pool, right? So you can see this task, right, is nothing but simply uploading the work of a main thread, right? So the task is going to be executed by a different thread altogether. But if you are using async and asynchronous programming, you are simplifying the asynchronous operation, right? But a new thread or a thread pool thread will come into the picture only when you are using await keyword. If you are not using the await keyword, then the execution is simply going to be like a synchronous manner. Clear or not?
Yes, sir.
So this
Right.
print counter can be any external API call also. This the
In this
method.
case, no, no. So here you need to write the external call.
Okay.
Right, and in the case of a print counter, if you want to use external call, that is also I'm going to show you, but in this case not. So you know what is a anonymous method, what is lambda expressions.
Yes.
Yes, sir.
So instead of using this print counter, right, I can use lambda expression, right? How to use delegate, can anybody tell me?
We need to start with delegate and pass parameters and then kick method.
Completed, this is delegate. So now here you can call your API. This is the delegate signature, na? Yes or no?
Yes.
And if I want to convert this to lambda expression, then can anybody tell me what is the
Arrow
process?
function.
This is the delegate. Clear? So within this lambda expression and the delegate, right? If you want to execute, if you want to call some external API, anything you can do. Clear? See, whenever it is expecting some delegate means you have all the options. Delegate means you can convert to an anonymous method. You can convert to one lambda expressions, right? Like this. And
And
not
there,
only this is applicable for the start new method, right? Even if you go to this task class, right? You can also do the same thing here. This is also possible.
And here itself we can use async await.
Sorry?
Like, and here itself inside task we can pass like this is an async of these braces, and then we can keep like await of
Where you need to, where you want to use async?
like inside that start new, like while inside that start new we
No,
can keep
not
async
required.
of-
Na. So in this case, this task is not going to be executed by the main thread. The main thread is going to execute this code, right? But this is a task. This is a task means it is going to be executed by a different thread altogether. Why we are going to use our async means whenever we want to execute the code by a different thread, in that case we are going to use the await keyword. But in this case already it's going to be executed by a different thread, right? We do not want to use async and await. For that purpose, I am only I'm using this task class. Right? Already we have discussed how to use async and await. Using async and await, you can implement asynchronous programming, and this is just another approach to implement asynchronous programming. So in this case, this method or this code, whatever you have written, right? So it's going to be executed by a different thread only, right? Let me show you this thing. Right here you can say I'm not calling any API, right? Sorry, I'm not calling any method, I'm using the lambda expressions, right? See, in this case you will see main thread and child thread ID are going to be same or different. So main thread started, main thread completed.
No sir, my
Yeah,
doubt is actually
we have not called the start method, that's why it is not executed, right?
sir, my doubt is actually inside that task we kept this lambda anonymous function, right? So here inside this method, if I'm calling one API, like one task that wait is there. So that time I need to keep await, right? So inside this for loop, if I'm like not in for loop, somewhere I'm yes, delay is there. Like there I need to keep await. So I need to be
You can.
yes,
But the
and this
thing is
method
that,
need to be
but the
start
thing
with
is that,
async.
but the thing is that this is a await. Await you cannot write inside a non-async block.
Inside task I can like that parameters are there, right?
You
Yes,
want to
before
make
that.
this as async.
Yes.
That is possible.
Yes.
That is possible, right? So,
Yes.
so what is required if you are going to use await, then you have to use async. And we have already discussed now how to create asynchronous lambda expressions.
Yes, that's what. Sir.
Right. So in this case, run the application. See, main thread is started by 1, right? Child thread is started by 3. This statement is started by 3. That 3 thread is going to execute this for loop. And here you are using await means the thread which is executing this for loop, right? That thread 3 is going to be released. And after some time, a new thread will come into the picture to execute this statement. And you can see here that thread ID is 4. So the same concept. Understand? Guys?
But this async and await is not required in task, no, sir? Is it?
See, again, I'm saying, so in this case, why it is not required? Suppose it's your main thread. You want this task, this for loop, what you are executing here, it is going to take some time, right? Let me do one thing. Sorry. Right? So this for loop is going to take some time, and you do not want that for loop to be blocked, or that for loop or this task to not block your main thread. So in that case, you can create a task, and this logic is going to be executed by a different thread. And in that case, you can see that the different thread, in this case, let's assume thread 2 executing this application code. And after this things are happening, right? Then what you need to do is you are going to call one API, right? That API is going to take some time. Let's say 1 second, or let's say 2 seconds, right? And that 1 second or 2 seconds, if you do not want the thread which is executing this code to be blocked, then you can use await, and you can only use await whenever your lambda expression is async. And how you can make the lambda expression async? By using the async keyword. And once you make the lambda expression async, and once you use the await keyword, right, the thread which is executing this particular task, not the main thread, the thread which is executing this task, right, that thread is going to be released, right? And once the why I'm going to release that thread, full thread, because that if I'm releasing that thread, right, then that thread is going to do a different task. And whenever the wait operation is complete, then again a thread will come from the thread pool and will start executing the rest of the code. Clear?
Okay. Got it.
Right. So basically it's completely depend on you. When you want to block a thread, when you want to release a thread, these things you have to implement. See, in this case, you can see thread 1, main thread 1, 3, and in this case, you can see child thread 3 started, child thread 3 completed. Means what? Now the child thread will execute this statement. The child thread is released at that time, and again that same child thread will come from the thread pool and continue its execution. It's possible that the same thread will come into the picture, or a different thread pool thread will come into the picture. We cannot simply predict which thread will come, right? So this is how you can make your async block and avoid of this thing. So we have seen the example of start method, and we have seen the example of start.new method, and we have seen how to make your lambda expression and how to use what? Anonymous method. Okay, let me show you one example using anonymous method. For anonymous, what you need to use? You need to use the delegate keyword. Simply remove this thing. It will become an anonymous method, right? So there is no difficulty to understand this thing, right? Let me comment this. And if you are using start.new method, no need to call the start method, right? It will automatically start executing this code, right? So let me run these things. See, 1 and you can see the child thread is executed by a different thread. Clear, guys? How to use start method and how to use start new method, right? How you can pass a method as a parameter to this start and start method, or to this task constructor, right? And the second thing, you have to understand how to use lambda expressions and anonymous method. So whenever one class or one method, right, constructor or method taking some parameter of a delegate type, right, then in that case you can pass a method as a method, right? Or even though you can pass anonymous method or lambda expression, right, whose signature is matched with the delegate. So in this case, you can see this delegate doesn't return anything, right? So you can simply pass this delegate, right? So in this case, you can see this is the lambda expression. I'm not returning anything, and this method doesn't take any parameter, right? So you can pass the lambda expressions, right? So these are the things you need to understand, right? Now the next thing is that, so whatever we have done so far, right, we can also do the same thing using run method, right? So there is one approach called the start method. Another approach is start new, right? Apart from these two approach, another method is run. But here, what you need to do, see, in this case, previously we have seen what? We have seen start new, right? In start new, what we have done, we have simply passed the function name as a parameter, and that is accepted. But in this case, you cannot simply pass the function name as a parameter. What it's saying, na koi is the specifier to run the threadful task, right? So in this case, the call is ambiguous between the task.run action, task.run.func task, right? So simply what it means you cannot simply pass, right, a method as a parameter. So what you need to pass? You need to pass a func delegate. So delegate means this is nothing but your lambda expression. By using the lambda expression, right, you need to specify the code, right? So in this case, you can see this is my lambda expression, and within this lambda expression, I'm calling this method, right? So this is how, and the functionality is going to be same as thread.start new, and in this case also a new thread will come into the picture from the thread pool to execute the print counter method, right? But here you need to specify by using a lambda expression. Again, you can do the same thing, right? If you want this code block to be executed by a delegate, right? Simply use the delegate keyword, right? This is going to be work. If you want, then you can convert this delegate to a lambda expression. This is also work. So previously in this lambda expression, right, this is fine. And inside this lambda expression, if you want, then you can also call this method. That is also fine. Right? So this is what you need to remember. So any question from anyone? See here, if you want to specify the method, right, then it is mandatory to specify by using the lambda expression. And if you are specifying lambda expression in the body, if you want to execute this statement, that is going to be executed. If you want to call a different method, that is also possible like this. Right? Behind the scene, this is going to do the same task. Right? So you can see child thread 3, main thread 1 and 1. Right? And even if you want, you can also execute this logic directly here. Right? Let me run this application. Clear? How to use run method, how to use start new method, and how to use start method. All these three are going to do the same thing. The difference is start. If you are using start method, then manually you have to, if you are using the task class constructor, then manually you need to call the start method to executing the method, to execute the method, or to execute the block of code or logics asynchronously. If you are using start new or run method, right, the method which is pointed or the logic what you want to execute, right, is going to be executed automatically by the threadful thread, right? If you are using start new and if you want to execute a method, then directly you can pass that method as a parameter to start new method. But if you are going to use the run method, then directly you cannot pass a method, right, as a parameter. If you want to pass a method as a parameter, then you have to pass that method by using the delegate, right? Directly you cannot. And this is the difference between start new and your run method. Clear, guys?
Yes, sir.
Right? So that is fine. So as of now, if you remember, right, what we have discussing now, we are just calling the method, right? And that method is going to be executed asynchronously. But in this case, if you see, whenever I'm running the application, the main thread not waiting for the child thread to complete its task. Main thread is not waiting for the child thread to complete its task. Now, what is my requirement? I want the child thread to wait. Then for that case, what you need to use? You need to use task.wait. Right? So once you call the task.wait method, right, then it will block the main thread until the child thread complete its task. So like the join method we have discussed in multi-threading, right? So it is going to be the wait method. So it will make the main thread to wait till the task one complete its execution, right? Now run the application and see the output. See, main thread started and finally main thread is going to be executed, right? It doesn't matter whether you use task.run or whether you use factory.start new, right? For everything, it is going to be same. Don't think that this wait method is working for start new or start or what you can say run method, because I'm calling this on the task instance. And how this task is created, whether using the run method or whether using the task class constructor or whether using the started new method, doesn't matter. You have to call this wait method on the task object. Now, see, in this case also, it is going to give you the exact output. Main thread 1 completed. Clear? How to wait that functionality? If you want to make sure one thread to wait until another thread completes its execution, then you have to call this wait method. Clear, guys?
Yes, sir.
Right? And we have discussed task using anonymous method and a lambda expression. We have already discussed these things, right? So how to use lambda expression, how to use anonymous method, we have already seen this example, no need to discuss again, right? Then what is a task? A task in C# is to implement task-based asynchronous programming, right? And was introduced with the .NET Framework 4. The task object is typically executed asynchronously on a thread pool thread that rather synchronously on the main, rather than running the application code synchronously. So basically, what is task means? So a task is a class basically used to implement asynchronous programming. Task was introduced as part of a .NET Framework 4.0, right? The task object is basically going to execute the application code asynchronously from a thread pool thread rather than synchronously on the main thread. If you are using task-based asynchronous programming, means what? Means your application code is not going to be run synchronously on the main thread. It is going to run asynchronously from the thread pool thread, right? And a task scheduler is responsible for starting the task and also responsible for managing it, right? So how it is going to start and how it is going to wait, all these things is going to be managed by the task scheduler internally. By default, the task scheduler uses threads from the thread pool to execute the task, right? The task scheduler, right, which is going to execute the task, the task scheduler will take the thread from the thread pool and start executing the application code. What is thread pool? We have already discussed. Let me give the definition. A thread pool is a collection of threads that can be used to perform a number of tasks in the background. Once a thread pool complete its task, then again it is sent back to the thread, right? Once a thread complete its task, then again it is sent to the thread pool so that it can be reused. This reusability of threads avoid an application to create number of threads which ultimately use less memory consumption, right? So less memory, less number of times the thread is going to be created means your application performance is going to be improved, right? Why do we need tasks? Already we have discussed. Now, if you want your application to be more responsive, if you want the main thread so if you want to upload the work of a main thread, right, then you need to use tasks. Clear, guys? Guys?
Yes, sir.
Okay.
Okay. Now another important concept is there. Uh, So which might be asking in the interview, how to attach child task to a parent task in .NET framework, right? Basically, if you are practically saying this thing is not used, right? Practically, you are not going to implement this thing in your application, but in the interview, they are asking this question, right? Let's try to understand what is this concept is, right? So how to attach a child task to a parent task in C#, right? So basically from this question, we need to understand two things. One of the thing is there should be a parent task, there should be a child task. And how we can attach the child task to the parent task, that is what we are going to discuss, right? So what is a child task? Child task, or you can say nested task, it is again a task, but this task is going to be created by another task called as the parent task. The child task is going to be created by the parent task, right? The child task can be either detached or attached, right? The child task can be either detached or attached. That means we need to understand these two things. What is detached and what is attached? A detached child task is a task that executes independently of its parent, right? Suppose you are created a detached child task, right? If the child task which is created by the parent task, if that child task is detached, right, then in that case what will happen, right? Both parent and the child are going to be execute independently, right? So for better understanding, you just look at this image, right? Suppose this is the parent task. Create one detailed child task and also create one attached child. How to create the attached child task, how to create detailed child task, that is what we are going to discuss, right? But for now, see, a parent create a detailed child task, right? Then in that case, will parent wait for the child task to complete? No. If the child task is a attached child task, will the parent wait for the child task to complete? Yes. If the detailed child thread throwing an exception, right? Is that exception is propagated to the parent task? No. If it is a attached child task, then that exception will propagate it to the parent, right? Then the child, or if the what is the child status? Is that affect the parent status? No. In this case, if, in the case of attached child task, is the child status is affect the parent task? Yes, it will affect. This is not clear. I know you have some question related to this, but once we start discussing, right, then you will get some better clarity, right? And guys, whenever how to create parent task, how to create child class, we'll see everything in practically. And guys, one point that you need to remember, by default, whenever a parent create a child task, that by default that task is going to be detached, right? And if you want to make the child task as attached, then you have to use this option. What is the option? Task creation option dot attach to parent, right? See, according to MSDN, in most of the scenario, it is recommended to use detached child task because the relationship of other tasks or parent tasks are less complex. Why? Now, if I'm making the task as detached, then that task does not impact the parent task, right? The parent task will not depend on the detached child task, but the parent task will depend on the attached child task. That means what? Now, if I'm creating attached child task, then both are going to be integrated together. If I'm creating detached task, then both are going to be executed independently, right? So let us see how to create all these things practically, right? So you know how to create a task, that is right. So this is my task, right? Don't forget about this code. So here you can see I'm creating task.factory.start new. So this is nothing but my parent task. So you can see I have provided a name as parent task. Inside this parent task, I'm doing some task. So you can say outer task started, or you can say parent task started. So instead of outer, you can mark this as a parent task started, right? So parent task started, parent task completed. Inside this parent task, I'm creating another task. And I don't need to explain how to create a task using start new, right? So instead of start new, you can also use the run method, right? But I'm not using the run method now. Why? I'm going to tell you later, right? So in this case, you can see I'm creating another task. Give me 1 minute, guys. Right? So you can see the way I'm creating the parent task, in the same way I'm going to create the child task. So we are simply saying it is a parent task, it is a child task, but technically this is nothing but a task. This is a task and this is also a task. But this task we have created inside the parent task. That's why we are saying it is a child task. Clear? And within the child task, again, what I'm doing, I'm saying child task started. I'm making the task to be sleep for 5 seconds. And then I'm saying child task completed. Clear, guys? How to create parent task and child task?
Yes.
Any question from anyone?
No questions.
So if you are confusing what is a var, then you can simply write a task, that is fine. Right here, instead of a var, you can simply type task, that is also fine. Right? So in this case, I have created two tasks, one parent task, one child task. This child task is created inside the parent task. That's why I'm saying it's a child of this parent. And in this case, by default, right? By default, this child task is a detailed child task. By default, this child task is a detailed child task. So as it is a detailed child task, does parent wait for child task to complete? Yes or no?
No.
No. So what it means? It means when you run this application, then you will see that whether the child task is completed or not, it will not impact the parent task. Here, you are calling the wait method on which task?
Main thread.
Main thread. That means it will block, right? It will block the main thread till the parent task completed, not the child task, right? Whether the child task completed or not completed, that doesn't matter. It will simply block the main thread until the parent task completed. And in this case, parent task will start its execution. It will create the child task. Child task is going to continue its execution. Then parent task will complete it. It will not wait whether the child task is completed or not. That doesn't matter, right? Let me run the application. See, you can see main method started, parent completed, then the child started, main method completed, child task completed. So in this case, does parent wait till the child task completed? Right?
No.
No. Why it is not wait? Because this is a detached child task. As it is a detached child task, so the parent will not wait whether the child is complete its task or not. The parent simply move on and do its work. And you can see, even though I'm calling the wait method, in this case, I'm calling the wait method on the parent task. So this main method execution will wait till the parent task completed. It will not wait whether the child task completed or not. If child task completed, that's fine. If not completed, then I'm not going to wait whether the child is completed or not. Parent completed means main thread will complete its execution. Clear? Guys?
Yes.
Right. Okay, how parent task will wait for the detailed child task to complete its execution? This is one important question, right? So how you will make sure, right? So what is my requirement? I just want this child task, right? I want this parent task to wait till the child task complete its execution, right? And in this case, there are two options, right? One option is, if it is the attached child task, then it is going to wait. That I will show you, right? But for now, what is my requirement? My requirement is how I can make sure the parent task will wait till the detached child task is going to complete its execution, right? For that, what we need to use now, in that case, we can use task operator. So what is task operator? That is what I'm going to show you, right? So in this case, instead of using task, we are going to use task of a string, right? So first of all, right, if you want any child task, right, any detailed child task to be wait, if you want your parent to wait till the detailed child task complete its execution, right? Then in that case, instead of using task, what you need to use, you need to use stack task of a string. Suppose I'm returning some string. So I'm writing these things. So I'm using the task of a string, right? This is task of a string, right? Then what you need to do here is, right? So here you need to use some return some data, right? Return some data, right? And then here what you need to write, child task. What is the child task dot result? What is? Hmm. I'm getting this error. What is wrong? Okay, so you can say this is my parent task, and now I have created using task of a T result, right? And in this case, I'm making this method to return some data. And here, instead of a task, I'm using a task of a string, right? And here I'm using the same approach, factory dot start new. I'm writing outer task started, child task started, child start, wait for 5 seconds, child task completed. And from this method, I'm returning task completed. And from this method, I'm returning child task dot result, right? So in this case, what will happen? Now this is the statement, and we have already know whenever we call the result property, then what will happen? Can anybody tell me what will happen? Guys, okay, so let me show you these things with one example. Static, async, task of integer from method. And what I'm doing here, I'm delaying the execution task dot delay for 2 seconds, right? And I'm also using the await keyword here, right? And here I'm returning some integer value, returning 100, right? This is my method, right? Let me comment these things, right? So what I'm doing here, okay, let me put this thing inside a region, region 1, right? So what I'm trying to do is, I'm calling this sum method. I'm calling this sum method, right? I can call this sum method. But in this case, can I use the await keyword here? I want the result. Can I use the await keyword here?
No,
Why I can't use?
because it is not a async method.
It is not a async method, but I want the result. I don't want to call this method. In this case, I will call this method, right? The method execution is going to be happen. But what this method is going to return, that is also I want here. Then what you need to do here? So in that case, you can write variable result equals to, right, some method dot result property. So in this case, right, so let me write the statement here, right? So main method started, right? And here main method completed, and here result. $, and here I'm printing the result value, right? So what will happen now in this case, until and unless the sum method is not completed, you cannot access the result what this method is returning. So in this case, what will happen? Now this result property, when you call on this method, will block the main thread. Will block the main thread until this method execution completed, and whatever this method return, that will be stored in this variable, right? So if I'm not calling, right? So in this case, okay, let me show you these things, right? If I'm simply calling this statement, right? So in this case, right? Okay, let me first show this thing, and let me put the statement also here. Some method started, some method started, and here I'm writing some method and completed, right? So in this case, you will see that main method started, main method ended, and some method is also going to be execute asynchronous, right? Let me run the application. See, main method started, some method started, main method completed, some method ended. That means what? Now, the main thread doesn't wait till the some method complete its execution, right? So in this case, you can see the main method started. When you call the some method also started. Then await keyword you use means main thread is released. Main thread is released means this statement you can see executed. And then after 2 seconds, the statement is executed and this value will be returned. But now what is my requirement? I don't want this statement block which I have written here to be executed until and unless this method complete and unless I receive this data. And if that is your requirement, then you need to call the result property. Then you need to call the result property. Once you call the result property, right? If you go to the definition, then what it's saying? Now it is saying that gets the result value of the task. It will return the result value of the task, right? Means until and unless it is not returning the data, it is not fetching the result of this task, the further this assignment statement or any other statement what you have written, those are not going to be executed, right? Now let me run the application, right? So you can see some method started, then some method completed, then result, and then main thread. That means what? Now once you call the result method, once you call the result property, right, then only it is going to block the main thread, or you can say the thread which is executing the code, right? It will block that code, and once this result is written, then only this statement is going to be executed. Let me put this thing inside our region 2 as region 2, and this is my arch end region, right? So now, so you understand what is the role of a result property, guys?
Yep. So
The
result will block the main thread until and unless it
not the main thread, the thread which is start executing the code. In this case, main thread, it might be suppose in this case another thread will be there, right? After suppose in this case thread 2 it start executing this code, right? Again, if you are doing some another asynchronous another call, right, and that method is returning some result, right, then in that case that particular thread which is executing the application code, it will block that thread. In this case, main thread is executing, so it will block the main thread. In this case, now coming to our application, right? Coming to our application, right? And this result property you can use only when your task is returning something, because this result will return the data what your method is, what your task is returning. If it's a value type task, then you cannot simply use the result, right? Suppose, right? If it's a value type task, you cannot simply return this result property. Why? Because this method doesn't return anything. Then what it will return? So only when your task is returning something, then in that case you can use the value. You can use the result property. Clear, guys?
yes.
Right? So in this case, that's why you can see what I'm trying to do is, first of all, this is the same example, and what changes I have done. First, I have converted this task to task of a string, right? This task I have converted to task of a string, and the child task also I have converted to task of a string, right? Now this child task is going to be executed, right? This parent task is going to be executed by a different thread. This child task is going to be executed by a different thread. And in this case, which thread created this task, child task? Main thread or this parent task thread?
Parent task.
I mean, the main thread ID is going to be one, right? But this parent task, which is executing your application, right? That thread ID might be different one. Let's assume that thread ID is 2 and the child task thread ID is 3, right? Try to understand. This is the thread ID, right? And this is going to be my thread 3. let's assume, right? We cannot simply predict which thread is going to execute this code, because that thread will come from the thread pool. That IT might be 2, 3, 4, 5, anything, right? So in this case, what will happen now? This thread 2 is creating these things, right? And this method returning some data, that is fine. But once you call this child task dot result, right, like this, some method dot result. So in this case, I'm creating this child task dot result, right? So if you are having doubts, sir, how is this possible? You are calling the method directly at the statement. You are not calling this on the task object, right? Yes, let's do this on the task object, right? So in this case, this method is going to return a task. See, in this case, task of integer. Now I am creating a variable. So let me do, right? Let me give this as a task, right? And in this case, what I'm going to do, I'm writing task dot result. That is also fine. So in this case, some method will return a task, and from that task, I'm fetching the result. So in this statement, it will wait till the result is written, and then it is going to execute the next code, right? The same thing is also happening here. Here you are creating the start, and this statement, what you have written here, it will block thread 2 until this child task is complete its execution, and until this statement is executed and this statement is returned. Clear, guys?
Yes.
So child task dot result means what? Now it will block the thread which is created, this one, right? And in this case, wherever you have written, right, this statement is going to execute only when this child task complete its execution, right? If this statement execution is not completed, means which task execution is not completed? You have written this statement inside your child task block or inside your parent task block?
Parent task.
That means this statement only going to be executed when the child task is completed, and you have written this statement inside the parent task. Inside the parent task means the parent task is only going to be executed or only going to be completed when this statement is executed. Clear? Yes or no, guys?
But since we are returning this result in parent task to, is it returning the result to, like, to which method it is returning the result?
First of all, tell me, is there any method I have created? This is a task. This is returning. See, in this case, this child task dot result means it's simply going to, this task is returning a value. Wherever you want, you can use that value. In the same case, this parent task. Okay, so in this case, so I can store this variable inside a string variable, string, right? Some value, right? String some value. I can write this thing here, right? And again, I can return this thing, return, right? Some value plus, okay, let first put this hello word, hello, some value, right? So in this case, what will happen? Now, in this case, see, whenever, okay, in this case, you just tell me parent task execution is going to be completed when which line number is executed. Bhargav?
Return hello.
Line number 30 is execute means the task execution is going to be completed. Yes or no?
Yes.
So that means whenever we execute this line number 29 only, the execution is going to be done. Right? Body is going to be completed. Yes, line number 29. But in line number 29, we are using some value. It's a string value. And this value we are getting in which line number?
24.
24 or 28? This variable where you declared?
Okay, 28, sir.
28. And you are assigning this value. And from where you are getting this value?
From child task.
Right, from the child task. And the child task is going to return the value when line number 24 is completed.
Yes.
And how to get the result of a task? By using the
Result property.
So in this case, whenever I'm executing this statement, child task dot result, that means the result what I have set written by this task is going to be returned. That means what? Now this statement will make sure that this child task is completed. Right? See, if this suppose this two statement is executed, this three statement is not executed, then can you access this value by using this result property?
No.
No, that means you can access this result property only when your task is completed. That means this statement will make sure your child task is completed, then only the rest of the assignment operation or any operation what you have written inside your parent task is going to be executed. Yes, clear? So in this case, this hello and whatever this child task return, that string is going to be written by your parent task, right? And again, guys, and now you just tell me, do I need to call this wait method here? No, I do not need to call this wait method here. And the reason is because I'm using parent task dot result. So the parent task dot result will make sure, right? Will make sure the rest statement is going to be executed only when the parent task is complete its execution. Yes or no?
Okay, so hello some value will be passed to parent dot result value.
So from where you return this value, just tell me. You are returning this value inside your parent task or inside your child task?
Inside the parent task.
Obviously, then that whenever you ask call this result property on the parent task, then only you will get this value, right? You cannot access this child task result from outside this, right? Here you cannot access this because this block is created inside the parent task only. Here this is not possible. Child task is not possible here, right? But parent task is possible because that block is available. This is inside this. This is a local to this thing, right? So now when you run this application, then you will see that, right, the child task is waited, sorry, the parent is wait till the child is complete its execution, right? Outer task started, child task started. Once the child task completed, what happened? Oh, so we have not written the read key statement, right? Child task started, child completed, then outer task completed, then main task is going to child completed, parent task return hello task completed, and main method completed. So in this case, you can see this is a child task, right? And using the result property, we can make sure, right, the child task is completed, then only this is going to be happen, right? Now, what I'm trying to do is I'm removing these things. I'm removing these things, right? And as I'm removing these things, so I cannot return anything from this method, right? And I'm not going to return anything from this method. So what I'm doing here, now I'm just calling child task dot wait method, right? Right. Now run the application. Right. So in that case, you can see main method started, main method completed, outer task started. Once the child completed, then parent completed. Why? Because we are calling the wait method, and we are calling the wait method on child task. Right? That means who created this child task? Parent task created. So it will block the parent task until this complete, until the child task execution is completed. And if you want to make sure, if you want to block the main method till the parent task completed, then you have to call the wait method on the parent task. Clear, guys?
Sir, in this, correct me if I'm wrong, sir. There are 3 threads, one main thread and 2 different threads will be created, but those threads will be in waiting period till the child thread of those thread will be complete. Is it? Sir?
Yes, yes, yes. So in this case, it will wait the parent thread to complete the child task execution. In this case, it will wait the main thread to until the parent task complete its execution. So 3 different threads is going to execute your application code.
Okay, thanks.
Right? So this is how, but in this case, you can see we are going to use the wait method. We are returning some task of a string. You are calling the result properties, right? All these things we are making because the child thread or the child task which is created, it's a detached thread, right? So instead of doing all these things, right, what we can do is we can create an attached thread, right? And once you create the attached thread, right, then the parent is going to wait, right? Okay, let me show you this thing. So in the case of a detached, it will not wait, right? If you want, then you have to do this manually. In the case of a attached child task, then parent has to wait till the child completes its execution. And how to create a attached thread, attached child task means you have to use this option, task creation option dot attach to parent. Let's see how you can do this, right? So if you go to the start new method, right? If you go to the definition of start new method, right? Then you will see that this is the first parameter, is the action parameter, right? And another overloaded version is there, right? Where you are taking the second parameter as a task creation options, right? You can see first is the action delegate and the task second parameter is a task creation option. And if you go to task creation option, it's basically an enum, and you can see there is a property called attached to parent. So what it specifies that a task is attached to a parent in the task hierarchy, right? So basically, if you want to attach a child task to a parent task, then you need to use the overloaded version, right? Which is taking the second parameter as a task creation option, and you have to provide attached to parent. So in this case, you can see this is the same example. In the previous example, we have only passed the action delegate. Now I'm passing the second parameter that is attached to parent, task creation option attached to parent. And once you pass this option, now this child task becomes a attached child task, and as it is a attached child task, so the parent task will depend on this task. Until and unless this task not completed its execution, this parent task will not complete its execution, right? So in this case, you can see I'm calling the wait method on the parent task. And in this case, it will only block the main thread, right? It will only block the main thread. But in this case, as you are creating this attached to parent means the parent thread will automatically wait till the child or the parent task will automatically wait till the child task complete its execution, right? Let me run the application. See, outer task started, outer task completed, child task started, child task completed, and then only the main method completed, right? So how the execution is happening? The execution is happening in this way. Your parent task will start, your child task is going to be start. Both are going to be executed asynchronously, right? Both are going to be executed asynchronously. You cannot give guarantee whether the parent has completed fast or whether the child has completed fast. And here you are calling the parent task to wait. Parent task to wait means this wait method will not only wait till the parent complete its execution, but will wait till the child also complete its execution, right? So in this case, you can see the parent outer task started completed immediately, right? Outer task started completed immediately, and when you call the wait method, then it should execute this main method immediately. But you can see main method is not executed immediately. After the outer task completed, it is waiting till the child task complete its execution, right? So if you are creating a detached, if you are creating an attached child task, then the parent task will wait till the child task is completed. So in this case, wait method means what? This parent task wait method will wait not only the parent task complete its execution, but also it will wait till the child task complete its execution. When both the tasks are completed, then only it will allow the main thread to be go and further execute the statement. Is that clear?
Yes,
Guys?
sir. Yes, sir.
So we have discussed what is attached child task, what is detached child task, and in the case of a detached child, by default it is not blocking the parent task, right? And if you want, then you have two options. One is you can use the wait method, and another one is you have to return some data from the task, and you have to use the result property. And we have seen by default this is happening in the case of a attached child task. Right, so this is what we have discussed. Now we have to understand one more thing. Right, now you want to you want the parent thread, right, should not accept any child thread. So what it means, now in this case you can see this attached to parent. I have created the child task using attached to parent, and it is attached to the parent task, right? But my requirement is that I do not want, I do not accept any child task as attached to me, right? By default, so what will happen? Now, by default, if you attach, then it is accepting. Now, I just want to prevent this parent task to be accept any attached child task. Then what you need to do, if you go to this class, right, you will see there is an option called a DNA child attached, right? DNA child attached means what? Now you have to create this class, right? Using what option? Task creation options dot DNA child attached, right? So once you provide this option, now what will happen? Even though while creating the child task, you are using this attached to parent option, this will not become a child of this parent. Why? Because you are preventing. So this statement means it will prevent any child task to be attached to the parent, right? So this will prevent. So in this case, once we call this wait method, right? So it will only wait till the parent task complete its execution. It doesn't matter whether the child task complete its execution or not, right? So now if you run the application, then you will see that main thread is only blocked for the parent thread, but it will not block for the child thread. You can see main thread completed, then only the child task is going to be completed, which means what? It means the DNA child attached means it will not allow any child task to be attached. Clear? Guys?
Yes.
Right. And another option is that, so in this case, we have discussed these things, right? And by default, right? So in this case, you are using task.factory.start new, and you are using task DNA child attached, right? And if and by see in this case, by default, if you remove this thing, right? So someone asked me what is the difference between start new and run, right? By default, start new will accept any attached child task by default. If you want to deny, you have to use that option, right? And by default, right, the run, if you are going to use the run method, right, and by default, it is not allowing you any child task as a it will not allow you to attach any child task. This is the difference between your run method and start with a new method, right? Now in this case, right, I'm running this application. I'm not using that deny child option, right? Deny child attach. I'm not using that option, But in this case, you will see that it will not allow, even though the child task is created using this attach to parent option, it will not attach to the parent, right, by default if you are using the wrong method. Right now, run the application and see the output. See, outer task started, completed, main method completed, child started, and after then the child task is going to be completed. So what is the difference means? Run method by default it will deny any child thread to be attached, and start new method by default it allows the attached child task to be attached. This is the difference between run and start with new. Clear?
Yeah, one question, please.
Yeah, ask me.
Besides the concept itself, does it have any application like in LinkQ or some other?
Yeah, see, LinQ is there, right? Parallel LinQ is there. We are going to discuss LinQ in detail. And for now, don't mix that LinQ concept into these things, right? LinQ is a very vast topic. I'm going to cover LinQ in great detail, right?
No,
So
but the question is if these concepts we're seeing now have an application for LinkQ and other database access or that kind of stuff. I'm asking if it has an application on database access and others.
See, yeah. So that is fine. We can see those things, right? LinkQ basically what? Now in memory object. So do you know what we mean by in memory object?
Nope.
Right. So basically, see, in database, you know.
Yes.
In database, you can perform different kind of operations. Like you can perform some set operation, intersect, except, union. You can perform some joining operation, right? Left join, right join, outer join, right? You can perform some filtering, right? Where call clause, group by clause, right? Many things you can perform in the database. Yes or no?
Yeah, right. I work with all those queries.
Right,
but
you have SQL queries, right, which you can fire on the database, and according to the query you will get the output. Now if you want to perform the suppose, so in the database you have table means it's a collection of record. What is a collection in our from C# programming point of view? What is a collection? A collection is simply a if you are creating a list collection, list of integer, a list of employees. Let's consider employees means what? It is a collection of employees. Yes or no?
Yeah, right.
So if you want to perform such operations which you are performing on the database side, and if you want to perform those operations on your programming language, then you need to use LinkQ queries. Anything, whatever, most of the thing you are filtering, you are set operation, joining operation, whatever you are performing on the database, you can also do the same thing on in-memory object in your C#.NET applications, right? In-memory object means you are creating a collection of employees. That collection of employees is nothing but an in-memory object. You can do the things here. Even though it is also possible that you can create the queries, right? Those queries is going to be executed on your database side. So you have the option, right? Option in the sense you can create a LinkQ query, and if you want some of the parties should be execute on the database side, that is possible. And if you want some of the part of the query is going to be execute at my application and in the C# programming, and then that is also possible, right? That is what we are going to discuss, right? Why I'm not touching the LinkQ concept here right now is because little knowledge is always dangerous, right? If I'm going to give some little information, then it will make you confused only to understand the concept, right? So, and there is no link between this task asynchronous programming with LinkQ. Yes, there is something called parallel. LinkQ is there, which we will discuss once we discuss parallel programming. But asynchronous programming, there is no link between your LinkQ. Parallel programming having some link with the LinkQ concept. That is the one concept you might know, parallel LinkQ, right? That is what we are going to discuss. Right?
Okay, I see. I was trying to find a relation between this and the databases, but as you just said, there is no relation. So I'll wait until parallel.
Exactly,
programming. Okay.
exactly. You just tell me why you are using asynchronous programming. We are basically using asynchronous programming to interact with some external system. External system means if you want to execute some, right, you are having some API, right? Then that API in the sense what? This is an external system to me. I just want to call that API. For that purpose, I'm going to use asynchronous programming. I'm having one method, right? That method is communicating with the database, right? And that operation is going to take some time. Then I can make that method as an asynchronous method, right? And then I can call that method from my query from here only, right? So basically, whenever you want to communicate with some additional, some external application, then in that case, you need to use asynchronous programming, right?
Okay, so I could have, for instance, a web API, which is serving the information about a database, is connected to a database and rendering results and all that. That's in web API. So you could query that using asynchronous programming.
Exactly, exactly. So you can see whenever we are developing any APIs, right? Most of the time, if you go to the go and see the signature of APIs, right? Then you will see that they are created using the asynchronous method, right? And whenever you are going to consume the API, right, you have to use asynchronous programming, even though it is not mandatory, but it is good to use asynchronous programming, right?
Okay, okay, thanks.
Right. So this thing I'm saying again and again, asynchronous programming means whenever you want to communicate with some external system, right? And in this case, you can say I'm executing this task, right? Those things it is even though it is possible, right? So in this case, you can call one external API. In this case, you can also call an external API, right? And you want to make sure that when this API, external API is completed, then only I have to remove from this task. Then you have to use that wait method or that result method that what we have shown you. But behind the scene, whenever you are using asynchronous programming, it should communicate with some external system. If it is not communicating with some external system, then don't use asynchronous programming. Clear?
Great, thanks. Yeah, clear.
Right. So in this case, you can see what is the difference between a run method and start new method. Guys, clear?
Yeah, it's clear.
Yes.
So run method means by default, it will not allow any child task to be attached. And if you are using factory.start new, then by default, it will allow the child task to be attached. Right. This is the difference between the run and a start new method. Right. Now what will happen? Say, as we have discussed, if it is a detached child task, right? If some exception is thrown from the child task, then it is not going to be handled by the parent task, right? So in this case, you can see this is my parent task using start.new option. And here I'm saying outer task started. I'm creating the child task, and here the child has completed, and then I'm completing the parent task, right? And you can see what will happen here. Now I'm making my application logic to throw an exception. Can anybody tell me which type of exception it will throw in this statement? From a line number, what line number it will throw which exception?
Divide by zero exception.
Divide by zero exception from line number 21. And you can see I have written all the logic, and here I'm making sure parent task dot wait. Parent task dot wait means what? I'm making the rest of the code to be executed, right? Only when the parent task complete its execution. But in this case, you can see the child task throwing one exception. Is that exception is going to be handled by this catch block?
No.
People tell me this child task, it is a attached child task or a detached child task?
It's a detached one. It is not going to handle that.
Right. So if it is a detached child task, right, then is it going to handle the exception? Yes or no?
No.
Right. So in this case, now if I run the application, then you will see that even though this statement line number 21, it will throw the exception. That means line number 22 is never going to be executed. So main method started, outer task started, outer task completed, right? Child task started, main method completed. After main method completed, you will never change this statement. Why? Because this line is throwing an exception, and this parent task will not wait till the child task completed. So this catch block will never going to handle these things, right? Now what I'm going to do is I'm going to make, right, this child task, right, as a attached child task. So tell me what is the option? Task creation option dot attached to parent, right? Now this child task is created as a attached child task. So this parent method will wait till the child task completes its execution, and while it is waiting, if the child task throw an exception, that exception is going to be captured by the catch block, right? So now let me run the application and show you the output. See, that exception is captured or not? Clear?
Yes.
Right? So this is how you can attach and detach child task from a parent task, and the different options, right, that you have to understand. Any question from anyone?
So like if I can relate this to async and await, if the detached child task is there, then we
See,
can
you cannot relate this to async and await. See, in async and await, from one method, from one async method, async and await means what? They are having different method only, right? From one method you can call another method, and while calling the another method, you have to use what? You have to use await keyword, and if you are using the await keyword, then only that is going to handle the exception. We have already discussed this thing.
no, so like in parent task here, there will be one thread running, and in child task, there will be another thread created for that separately, and it will complete separately in detail.
Not created, that is going to use the thread
Use
pool.
the thread pool, sorry, yeah.
Exactly.
So it is the same case like sync and await, no, in that sense.
Yeah, exactly. See, in this case, I'm showing you this thing. Okay, let me create some static async task, right? And I'm saying this is method one, right? From this method, I'm creating a few async, another async, right? I'm creating this is method two, right? And here I'm calling a method two, right? So while I'm calling method through, it is throwing some exception. So new application exception, let's throw, right? Some exception it is throwing, right? So in this case, this method, right? So this is one async method, that is also another async method, right? So in this case, as you have not used the await keyword, and whenever this method is executing, this method throwing an exception, right? Even though if you write this statement inside the try catch block, right? You have written this statement inside the try catch block. If this method throwing the exception, then that exception is not going to be handled by this catch block, right? But if you use the await keyword, right, then only it is going to handle that exception by this catch block. This thing we have already discussed, right? The same thing is also applicable here. So in this case, you are attaching to the parent means what? The parent method will wait till the child method complete its execution. And while it is waiting, if the child thread throw an exception, then that exception is going to be handled by the parent, right? In this case, you are using this await keyword. You are using this await keyword means what? You are waiting till the method to complete its execution. And while you are waiting, if that method throw an exception, then that exception is going to be handled by the catch. If you remove this await keyword, or if you remove this this option, then in this case, does this parent thread wait till the child to complete its execution? No. If it is not waiting, then it doesn't matter whether this block of code, whatever you written inside this child task, throwing exception, completed, not completed, it doesn't matter to parent task at all. The same thing in this case also. It doesn't matter whether the parent method 2 completed with successfully or completed with error. It doesn't matter to method 1 because he is not waiting till the method 2 complete its execution, right? If he is waiting, then it is matter. Clear?
Yes, good.
Right. So we have already discussed these things, right? The last piece what we are going to discuss, it's a small one, or you can say it is a not used one, right? Not used one, or you can say a small one, right? Chaining task by using continuation task, right? So while working with asynchronous programming, it is very common to invoke one asynchronous operation from another asynchronous operation, right? So in this case, you can see this is one asynchronous operation and it is another asynchronous operation, right? Suppose here this operation taking some integer parameter, right? Then you can pass some data here, right? So this is a very common thing you can see, right? While working with asynchronous programming, it is very common to invoke one asynchronous operation from another asynchronous operation, passing the data once it complete its execution. What it means? It means once this method one complete its execution, right? Then only I need to invoke this method by passing some data, right? So this is what it is saying, right? That is once the first async operation complete its execution, then it will invoke the other async operation by passing the required data. This is called continuation, and in the traditional approach, this has been done by using the callback method, which is a little difficult to understand. So we have already discussed the callback method mechanism, right? Callback method mechanism is what? Callback method mechanism means we are calling one method, we are passing one delegate, and we want that method to invoke the or that delegate at some point of time. The same thing you can also achieve in asynchronous programming by using continuation task, right? So, but on earlier or traditional, we have generally used callback method, which is a little bit difficult, not that difficult, but yes, little bit difficult to understand. But I don't think it is difficult. But yeah, sometimes for some fresher, right, some beginners, it is little bit difficult to understand the callback method concept. But with the introduction of a TPL, right, what is task parallel library, we are going to discuss in detail from tomorrow. The same functionality can be achieved very easily by using continuation tasks, right? So in simple word, we can define a continuation task as an asynchronous task that is going to be invoked by another task that is known as at instant, right? So let's see how we are going to use this concept. So it's very simple. You can use task.run method or task.start new method, right? So in this case, you can see this is my task one, right? In this task one, whatever the logic I have written inside this method, that logic is going to execute, right? So in this case, or any logic you can write here that is going to be execute. And what is my requirement? Now, once this task complete its execution, whatever this task return, that I will pass as an input parameter to my next task. So in this case, this is task one, and this is my next task. So whatever the logic I have written inside this method, once that logic is completely executed and whatever the data it is written, that will come as an input parameter to my next task, right? So in this case, what it is returning? It is returning it 12. And this attendance, right? It is going to be task of int, right? It is going to be task of int. And if it is task of int, then by using which property I can access that value 12? Can anybody tell me?
Result.
Result property, right? So you can see here I'm writing the square of attention dot result is result into result. So in this case, it is going to return this value, right? And once this value is written, then how I can access by using the task of 2? By using the result property. So for this task, you can access the property, you can access this value by using the result property. And once the whole task or this task is completed, right, it is going to return a string. So you can see I have written this as a task of string, and I can access the result property or whatever this task return, right, by using the result property, right? So nothing is new, already we have discussed. Only thing that you need to understand is this continuation with means once this task is complete, please continue with the next task, right? And whatever input you want to pass, you can pass that as a task of task to this second task, and from that task you can access the property value, right, by using the result property, right? And this is the same thing, right? Whatever I'm using done using the start with new method, I can also achieve the same thing using the run method, right? So in both the cases, it is going to give you and perform the same thing, right? Now, if I run the application, then it is going to give me the string value, right? What is written by the second. The square of 12 is 144. So this is not useful that nowadays, right? But yes, this concept is also available, and I don't understand what is the exactly use of this thing, right? But there is no need. If I want to execute this logic, right, why I'm going to do this? If I know 12 is there, then I can directly return the things from that task only, right? I don't understand what is the real-time use case, because I never used this concept in any of my real-time application, right? Scheduling different continuation task, right? Let me show you this thing with also with one example, right? So this is my task, right? I have created the task, and this task is return 10, right? And this is task of a integer. Why? Because it is returning 10. Then I'm writing task dot continue with. Continue with I'm passing that I. See what is I? I is nothing but task of int. So whatever this task return, task of int, that will come as a parameter to these things, right? And the task and here I'm just saying that the task is cancelled, and how you can make sure only on cancelled property, right? So you have to task a continuation option, right? Having few properties, and you can use those properties. And here I'm using cancelled property, and I'm using halted property, task halted, right? And here I'm using task completed property, right? So if the task is halted, then this block is going to be executed. Sorry, if the task is cancelled, this block is going to be executed. If the task is sent through some error, right, then this block is going to be executed. And if the task completed successfully, then this block is going to be executed, right? So in this case, am I throwing any exception from my task? So from this block, am I throwing any exception?
No.
So am I canceling the task? No. So what I'm doing here, see, I'm using that the cancellation token source, right? CTS.tag, and so I'm canceling the execution by throwing that task cancelled exception. Anything I'm doing here? No. So this task means it is completed successfully. If this task is completed successfully, then this piece of code is going to be executed, and you will see task completed in the output. Clear? So this is not that useful. Don't waste time learning this continuation task concept. Right? Any question from anyone?
No, sir.
So what it means now, this block is going to be executed only when the task is cancelled. This block is going to be executed only when the task is throwing some exception, right? Halted mean exception, right? And this block is going to be executed only when your task completed successfully. Only ran to completion, right? We have discussed ran to completion. What is the use? Specifies that continuation should be scheduled only if its attendant ran to completion. Ran to completion means the task execution completed successfully, right? So, okay, let's do some trial and error. So instead of this, let me throw some exception. Throw new application exception, right? So I'm throwing some application exception here, right? Right, let me run the application. Okay, so one more error, a task was cancelled. So you can see it is coming to here, and I have not handled that error, right? So you can see that exception is coming, right? So what you can do is you have to handle the exception, right? So this is the use, but I never used this thing practically. And if anybody working with any real kind of application, if they might be seeing this thing, then the use of this thing is that based on the input, right, of one task, you want to execute another task, right? And this task is going to be executed only when the task is cancelled, when the task is faulted, and when the task is completed successfully. Clear? That's it, all about asynchronous programming. From tomorrow, mostly I think 3 classes I will take to complete the parallel programming concept. Anybody having any question related to today's session?
No.
Okay. And guys, please do practices multi-threading, asynchronous programming, delegates, right? Because these 3 things are interrelated. You can see the multi-threading concept we are using here, delegate concept we are using here, right? So be practice with multi-threading, delegate, and what you can say asynchronous programming. Parallel programming, it is completely different than your asynchronous programming, right? And which is very interesting, right? So if you want to increase the number of requests that can handle your application, then you need to go with asynchronous programming. But if you want to drastically improve your application performance, right? If you want to increase the performance of your application, then you have to go with the parallel programming. And how, that is what we are going to discuss from our next session. Thank you guys for attending today's session.
Thank you.
Thank you.